Hey guys, today we're looking at geometric sequences and series. So, whereas arithmetic sequences and series, we were adding the same thing every time, geometric sequences are a sequence in which the ratio of any term to the previous term is constant. So we're multiplying the same thing every time. And in this case, we use the letter R for our common ratio. So looking at these examples, we go from 4 to -8 to positive 16 to -32. We're definitely not adding the same thing every time because it's bouncing from positive to negative. But if you look, we're doubling and it's changing signs. We're multiplying by -2 here each time. So times -2 for each of those. So this would be yes, this is geometric, and our R value then would be -2. That's what we multiply by. Okay, if you look at this one, going from 3 to 9, we're multiplying by 3. Then from 9 to -27, we're multiplying by -3. And then -27, and it stays -81, we're multiplying by +3 again. So that one's a no. It does not have a constant ratio that we're multiplying by every time. All right, so our rule for our geometric sequences looks kind of similar to our rule for arithmetic. A sub n, our nth term value, is equal to a sub 1, our first term, times the ratio, instead of difference there. Notice we used a times instead of a plus. And then it's raised up to the n minus 1 power, whereas when it was the common difference, it was multiplied. So you need to know that rule as well. Write out the rule for 2, 16, 8, or 2, 6, 18, and 54. So we use a sub n is equal to a sub 1, which is 2, times our common difference. What is happening every time? Well, 2 to 6, 6 to 18, 18 to 54, we're multiplying by 3. And then that's to the n minus 1. And we can't simplify that n minus 1 any more than that easily, so that is how we leave that rule. There's no simplifying there. Alright, for example 4, it says write a rule for this sequence, 5, 2, 0.8, 0.32, and then find a sub 8. So, a sub n is equal to our first term of 5 times, what's our rule? What's happening every time? If you're not sure, remember you can always divide backwards. So 2 divided by 5, that's 0.4. 0.8 divided by 2 is 0.4, and so on. So 0.4 is our rule to the n minus 1. So there's our rule. Now we're going to use that to plug in 8 everywhere we see an n. So 5 times 0.4 to the 8 minus 1. So we get 5 times 0.4 to the 7th power. And that would be 0.008192. That's our 8th term here. Alright, example 5 says write a rule for a geometric sequence with a sub 4 equals 3 and a common ratio of 3. So what I noticed right off the bat is we don't have an a sub 1. So we're going to have to go through and find our first term. But we can do that if we know that our fourth term is 3. We don't know a sub 1. We know our common ratio is 3. And we know we are dealing with the fourth term. So 4 minus 1, well, that gives us 3 as well. So 3 to the third. 3 to the third is 27. So then I can divide by 27 on both sides. 3 over 27, hopefully you know that that reduces down to 1/9. So our a sub 1 value is 1/9. So then plug it back in. A sub n is equal to 1/9 times our rule 3 to the n minus 1. And we put n back in because it works for anything. We don't put a value in there. Again, we're not going to spend a lot of time talking about this, but the graph of a geometric sequence is made with dots as well, but instead of it being linear like arithmetic, it's exponential. Alright, write a rule for the geometric sequence with a sub 2 equals negative 4 and a sub 6 equals negative 1024. Alright, so no first term, no common ratio. We have some work to do here. So I'm going to put negative 1024 is equal to a sub 1 times r to the 6 minus 1. I'm going to put negative 4 is equal to a sub 1 times r to the 2 minus 1. Well, I know I can simplify those. Negative 1024 is equal to a sub 1 times r to the 5th. And negative 4 is equal to a sub 1 times r to the 1st. So what I would do probably is just to divide these. Because if I divide these, negative 1024 divided by negative 4 gives me 256 is equal to a sub 1 divided by a sub 1, those go away, and then r to the 5th divided by r to the 1st is r to the 4th. So the 4th root of 256 is plus or minus 4, right? We have to put the plus or minus in there when we're solving. So now, this creates a little bit of ambiguity when we are writing our rule here. Because if it's positive 4, one thing happens. If it's negative 4, another thing happens. So if r is positive 4, let's work in that case. I'm going to use this negative 4 second equation that we started with. So negative 4 is equal to a sub 1, we still don't know, times 4 to the 1st power, right? This equation over here is what I'm using. So then I divide by 4, since that's 4 to the 1st. I get a sub 1 equals negative 4. Or sorry, negative 1. Negative 4 divided by positive 4 is negative 1. So that rule would be a sub n is equal to, we used r as positive 4, a sub 1 is negative 1 times positive 4 to the n minus 1. However, if we use negative 4, we still have negative 4 is equal to, we don't know, a sub 1 times negative 4 to the 1st. If I divide by negative 4 on both sides, I get a sub 1 equals positive 1. So then this rule would be 1 times negative 4 to the n minus 1. Those are a little bit different. And the reason we have this case is because we have even terms here. So we don't know what's happening in the odd terms. We don't know whether it's switching back and forth from positive to negative, which would make our ratio negative 4, or if it's staying negative the entire time, which makes our first term just that negative 1. On a test or a quiz, there probably will not be this ambiguous case. You'll have an odd and an even. You'll know what's happening there. Sum of a finite geometric series looks like this. So a little bit different than what ours looked like before. So S of n, the sum of n terms, is equal to our first term times 1 minus our ratio to the nth power, so some number of terms, over 1 minus our ratio. So the sum of the first 10 terms is what this is asking for. Notice we don't need to know what that 10th term is in this case to find it. So we want to find the sum of the first 10 terms. Well, our first term is 4, And then we have 1 minus. What's our ratio? What's happening every time? How do I get from 4 to 2 and then 2 to 1? Well, I'm dividing by 2, but that means that I'm multiplying by 1/2. So 0.5 is my ratio. To the 10th power, since it's the sum of the first 10 terms, and then 1 minus 0.5. So I have 4, and then 1 minus 0.5 to the 10th. I'm going to wait to plug into the calculator, but 1 minus 0.5 is 0.5. So then I can do 4 divided by 0.5 to make life a little easier. I'm just trying to make it so I have less to type in the calculator that I can mix up, but you could type the whole thing in there if you're comfortable putting all of those parentheses in. And I get about 7.9921875. That's actually probably exactly that, but it's not a great value there, but 7.9921875. All right, find the in value such that the sum of that number of terms is 31 over 4. So we know our answer over here is 31 over 4. We know our first term is still 4, but we don't know, still 0.5 ratio, we don't know what that nth term is. We still have 1 minus 0.5. So let's see what we can do here. I'm going to go ahead and say this 31 over 4 is equal to 4 times 1 minus 0.5 to the nth power over 0.5. Just like I did before, 4 divided by 0.5, that's 8. So 31 over 4 is equal to 8 times 1 minus 0.5 to the nth power. I'm going to divide by 8 then on both sides instead of trying to multiply that 8 in, because there's that exponent of in there. So 31 over 4 divided by 8. Well, since I'm dividing by 8, it's the same as multiplying the denominator by 4. I get 31 over 32 is equal to 1 minus 0.5 to the nth power. Now I'm going to subtract 1 from both sides. So I get, and subtracting 1, that's the same as 32 over 32. So 31 over 32 minus 32 over 32 would give me negative 1 over 32. Negative 0.5 to the n. So if I divide both sides by negative 1, then I get 1 over 32 is equal to 0.5 to the n. So then we still have that n up there that's unknown. That means we got to use some logs here. So logs are coming back to us again. So flip this around into our log notation. N equals log of 1 over 32 base 0.5. So remember, you can use your change of base to put that in your calculator. And we get n equals 5. So what that means is if you add the first 5 terms together, you would get 31 over 4. Alright guys, that's all I have for you for today. If you have questions, feel free to come in and see me. Otherwise, I will see you in class.